Employment data at a large company reveal that 72% of the workers are married, that 44% are college graduates, and that half of the college are married. So, draw a Venn diagram to represent this situation.
Venn diagram, the circle thingies?
Yeah. So you're going to draw a big box. And then inside of there, draw 2 circles. Not oval.
Your money jar is filling.
Making bank.
It's not a circle.
Alright, so I'm going to use like orange or something. Not purple. Hello. Orange.
I'm gonna use
Same color I'm already writing with. Hello. Okay, so draw a Venn diagram to represent this situation. Well, we need to almost always look at the part that is both first because you've got to subtract the both part from the other circles because there's overlap in this problem. Okay? We know there's overlap because it says half of the college graduates are married.
So it's 22.
Okay? So yeah, so if you look at there are 44% of college graduates, then half of those are married, so that would mean 22% is both, so we'd put 0.22 in here. And I'm going to label that as both. So then I'm going to do married, college grad.
You still subtract it?
So yeah, so you would do for college grad, let's just go ahead and get that one out of the way because that's kind of the easier one. Half the college graduates are married, so I'm going to take the other 22% is not married, so 0.22 are college grads that are not married.
So then you add them together and subtract 100?
Well, for married, we don't know that everybody is in either category. Does that make sense? There might be some that are out here that aren't either.
So you just subtract 22.
So we're going to do 72 minus 22.
52. No, 50. It's 50.
So 0.50. Then look at this. Does this add up to 100? What's in the circles? If it doesn't add up to 100, we're going to do 1 minus that, and that's going to be everything outside.
It doesn't add.
So what is 1 minus that?
1 minus 1.
Everything in the circles. 0.6? 0.06.
0.06.
Oh, 0.06.
0.06.
Yep. I knew there was a 6 and a point.
There's a hair on my iPad. There we go. What is the probability that a randomly chosen worker is neither married nor a college graduate? So that's what we just found, right?
0.06.
0.06. What is the probability that a randomly chosen worker is married but not a college graduate?
0.50.
What is the probability that a randomly chosen worker is married or a college graduate?
0.72.
You have to multiply.
Yeah, 0.72.
Okay, well, hold on.
Oh, wait, no. 0.44.
Because it's or, right? So you have to
0.44.
multiply them.
So we would do the probability of A plus the probability of B minus the probability of A and B.
Which one's A and which one's B?
Huh?
Which one's A and which one's B?
It doesn't matter. You can pick whichever one you prefer. I'm just writing the formula so you have it now. I don't really care if you write the formula every single time.
0.5
Like actually writing the formula every time, but you probably should write out the numbers, because if you just give me an answer and I don't know where you got it from, I can't really give you any credit if it's wrong.
Wait, what? Which one is A?
So the probability of A, let's just say that A is married. Probability of A is 0.72 plus the probability of B is college graduates is 0.44.
What?
We're just doing the probability of married.
But I thought point
So
15
it's
was
72.
married.
We're looking at original because we're doing the formula. So the probability of A is 72.72. Probability of B is 0.44. And then we're going to subtract the intersection of the two, because that's the stuff that's getting counted twice. Minus 0.22.
Will we also subtract the 0.06?
No, because it's
Oh.
married or a college graduate. It's not asking about neither.
You know, why don't
But
you
isn't
just...
that part of the whole? And that it's either married or college, so it wouldn't
Well, married or college is the addition rule. They're not independent. So we add the two things and we subtract the intersection of the two.
Oh.
Oh.
How long
yeah.
has that answer been now?
Like a minute or so.
I really just did the math on my calculator.
You started doing math before the numbers up there, right?
Yeah, I think you were typing it before.
Yes.
Okay, the other option is you could have done 1 minus the probability that they're neither. Technically, you could have just added up everything that's in the Venn diagram.
And then subtract it by 6.
No, I'm sorry. I should specify. In the circles of the Venn diagram. Not the whole box. So yes, if you add everything up, it should be equal to 1. And then you would have to, subtract off the neither, but... Two events, A and B, are independent if the probability of A is equal to the probability of A given B.
I did the same thing. Oh no.
I was trying to fit the whole thing on here, and then I was like, nah, I probably should wait.
The hairspray on my hair is gone. I can feel the black of it. It was like crunchy this morning. So I'm glad it's more gone. Yesterday, okay, it was really bad because I went to straighten my hair because I had to straighten it before it, and then I was like, what if I just don't straighten it? And then it gave me like George Washington curls. So then I waited for them like to cool and like see if I brushed it out would it look okay, and they just looked really frizzy and really bad. So I had to straighten it all over again, and I had to put hairspray in it, but I brushed it and had to put hairspray in it already. So like the hairspray was like stuck in my brush and it was hurting my head really bad.
What is my hair doing? Like it's like
It's taking a step.
It's like
It's the fact that there's like hair at the bottom.
it's like a whoosh.
It's the fact that there's this piece stuck to it that just sticks out further than the rest.
Bruh. What is this?
It's okay. Miss Hughes tried to pull a hair off my mask today that was attached to my head.
Don't pull
She
it
was
out.
like, "Oh,
Don't
you've got
pull
a
it
hair
out.
on your mask," and she started pulling it. I was like, "That's attached." All right. 56% of all American workers have a workplace retirement plan. 68% have health insurance, and 49% have both benefits.
Actually, this one's easy. It gives us everything we need to know.
Basically, yes. Draw a Venn diagram to represent the situation.
Why'd they write 56 out?
So, I'm just going to tell you, I'm going to represent retirement plan by RP and health insurance by HI. And, both with like a B or something.
Oh.
doesn't really matter, but just,
Hi.
This one's more than 100 though.
well.
No, you need to subtract them.
All right, so retirement plan, health insurance. 49% have both, so we know in the middle where both is, we've got 0.49. I'm going to change colors so you can actually see what's going in here.
Look at how good that Venn diagram looks.
It looks a lot better than the first.
Good looks better. Look at it.
All right, so 56% of all American workers have a workplace retirement plan, but 49% have both. So, how many people just have a retirement plan?
56.56.
56%. 0.56.
No.
That's how many total have a retirement plan, but 49% also have a health insurance plan.
Wait, it's 5, right? 0.5? 0.005?
Oh wait. Oh wait. Oh wait. 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 Wait.
0.56?
Wait. No. Wait.
Just
Hold on.
said
Give me a second. Give me a
49
second.
minus 56 is 0.5. 0.6.
Wait. No.
0.7.
It's not 0.7.
0.07.
07.
0.07.
I don't know how to do math.
Okay, so 0.56 minus 0.49 is 0.07. So then for health insurance, 68% have health insurance, but 49% have both. So how many just have health insurance? 0.19.
Yeah, I was gonna say that.
How many have nothing?
Hold on.
Over
6 plus 49. 26 plus 49. 4, 5, 6, 7. 70. 5. 25. I'm so
For
smart.
real? I got 0.85.
It broke his head. And I did it all
You have
in
to
my
add up
head.
everything in the circles and do 1 minus that.
Oh, I didn't do 1 minus. But I would still not get. I did.
Did you do it in your head? 7 plus
Oh.
19 is
Okay.
26
So
plus
basic.
49 is 75.
Why am I stupid?
I took a long time to do that in my head.
I put that 5 plus 1 is 8.
Where did you have to do 5 plus 1?
No, wait, not 5. No, 6 plus 1. I put 8
Where did you have to do 6 plus 1?
in my on my paper.
There's
I
not
guess.
even a 6 and a 1.
All right, so B is what we just answered. If a worker is selected at random, what's the probability that he or she has neither health insurance nor a retirement plan? So that's just your everything outside the circles, 0.25, okay, or 1 minus 0.07 minus 0.49 minus 0.19, just in case you need to see it when you go back and look at stuff. The next one, if a worker is selected at random, what's the probability that he or she has health insurance if he or she has a retirement plan?
49. I'm guessing that's not the right answer. 19.
We're gonna use this thingy. So we're looking at the probability that they have health insurance given that they have a retirement plan.
Isn't it this point?
So the probability of health insurance given a retirement plan.
Okay, so it's 0.19.
Okay? I will tell you, sometimes the book words these weird. And they'll say something like, given that they have a retirement plan, what is the probability they have health insurance? They'll actually write it backwards. So make sure you pay attention to wording with these ones. Okay? Don't let it confuse you and just think that the first thing they write is always the first thing that's going there. Okay? This one happens to be, there might be an example in here that's not like that.
Can you just put
Well, this is the formula. So it's the
0.7 plus 0.19 divided
I
by
got 0.01.
It's not right. You have to do another formula after. I remember.
it's
Isn't
the
it-
probability of health insurance intersected with a retirement plan
Oh my goodness gracious.
divided by the probability of a retirement plan.
Oh,
Okay, my question is. No, I actually don't have a question
so
anymore.
then isn't that 0.07 plus 0.0?
Okay, we're gonna have to go a lot
plus
slower.
0.19 divided by 0.17.
So the probability that it has both is the middle section of your Venn diagram,
So
which
both
is
on the top.
0.49.
So,
Okay, so the intersection of the two circles is 0.49, so that's what's going on top.
Oh, I
0.07.
see. I get it.
Or, well, actually, sorry, it shouldn't have the decimal point because we're dividing this stuff. So 49, yeah. So sorry, it should be the whole numbers, not the decimals.
So 7.
And then on the bottom, we want the total probability of retirement plan, not from the picture. Okay, we want the total that have a retirement plan, not just the one. So yeah, so it's gonna be 49 out of. I love how I just thought that doing that was gonna make you be able to see the problem. There we go. So it's gonna be 49 out of 56, and that gives you what decimal? 3 decimal places.
I can't do that.
0.875.
0.875. So the probability that they have health insurance, given that they have a retirement plan, is 0.875.
Oh, that's pretty good.
No.
Are having the two benefits mutually exclusive?
No,
Why?
because you don't have to have a retirement plan to have health insurance. Oh wait, yes, they are mutually exclusive. You do have to have a retirement plan to have. I don't know. 'Cause I have
The-
I have
I
health
say no,
insurance and
I
I
say
don't have a
no.
retirement plan.
That's, yeah, yeah.
Okay, this is implying like this would be like your mom's thing because it
So
would be
yes.
like she works, I guarantee she has a retirement plan and she has health insurance. So if there's ever overlap, they can't be mutually exclusive.
Is there overlap?
Both.
So no.
Okay.
If there's ever something in that middle part of the two circles,
Okay, so it's
there's an overlap.
So if
So
they're
n-
telling us to draw a Venn diagram, and then it asks us this question, we can just say, no, there's no overlap, or there's overlap.
Yeah,
No.
there's overlap. 49% have both.
49%.
If even 1% has both, they're still not mutually exclusive.
Okay. So this is kind of like one of those causations, not mutual correlation, not causation.
Okay, so then the next question here, I don't have a ton of room, so I might have to just like write it up to the side or something. For the math part, I won't, but then to explain it, I might. So, are having health insurance and a retirement plan independent events? The way we find out if it's independent is this P of A is equal to P of A given P of B. Or P of A given B. So,
I remember what I had for that.
I thought we did that though.
So I'm going to use the stuff that I've already found. So the probability of health insurance given a retirement plan, meaning I'm going to compare this to the probability of health insurance. So the probability of health insurance
Is that not a
is
dividing
equal
line?
to the probability of health insurance given a retirement plan.
Where? How is that equal?
I'm saying that if they're independent, it has to be equal. So if they come out to not be equal, I'm going to put a slash to the equal sign to show that they're not.
Is that line in the
This
middle?
is, if this is a true statement, then they're independent.
So they're not because
Well, so
HI
the
is-
probability of health insurance
56.
is 68%. So 0.68, is that equal to this 0.875 that we got for health insurance given a retirement plan? Those aren't equal. I'm going to put a slash through it. Here, I'll do it in another color so you can see it. I'm going to put a slash through it, and then it's going to ask, are they independent?
No.
Because
So, here, I'm going to try to section this off so I can write here. So, no, they are not independent. And then just as a note, if someone has a retirement plan, they are more likely to also have health insurance. Okay, a lot of times people do have both, but just because they have one doesn't imply that they have the other equally. So,
Well, we finished that report